3 billion. I mean, just let that sink in for a second. That is a mind-boggling number. We're not talking about the number of active users on a social media app or the stars in a small galaxy. 3 billion is the number of new tires produced globally every single year. It is a scale of manufacturing that is honestly almost impossible to wrap our heads around.
To really put that staggering figure into perspective, if we took those 3 billion tires we produce annually and just stacked them on top of one another, that rubber tower would stretch approximately 675,000 kilometers straight up into the sky. That is nearly twice the distance from the Earth to the Moon, and we do this every single year. This really sets the stage for the massive scale of what we're going to explore today.
Hey everyone, and welcome to today's Explainer. I was absolutely blown away when I started digging into this data, because today we are uncovering the unseen environmental impacts of our daily commute. It's a topic that affects almost every single person on Earth, yet it largely remains completely invisible to us. We're going to follow the science to see exactly where the rubber meets the road.
All right, here's the roadmap for today. We'll start with the global tire crisis, unpack the complex chemical cocktail inside a tire, ask, where does the tread go? Examine the threats of toxic runoff and 6-ppd, and finally, look at the end of the road. Let's get right into it. Section 1. The global tire crisis and its environmental toll. So, it all starts as this massive, continuous loop. You've got the huge extraction of raw materials needed for production, moving through a tire's useful life on our cars, the emissions it generates along the way, its eventual fate and transport out into the environment, and finally, to its reuse or disposal. It's an endless cycle, and the resources required right at the very beginning are enormous. Just think about the hidden costs here. They're honestly staggering. To get the natural rubber for the tread, massive tracts of highly biodiverse forests are completely cleared from monoculture plantations. Since 1993, in Southeast Asia alone, we've lost at least 4 million hectares just to rubber tree cultivation. And the manufacturing? Making a single tire takes an average of 45 liters of water and 6 megajoules of electrical energy. Plus, that whole process is pumping out nasty emissions like nitrogen oxides, benzene, and polycyclic aromatic hydrocarbons right into our atmosphere. Part 2. A complex chemical cocktail inside the tire. You know, we call them rubber tires, but only about 50% of a tire is actually rubber, and even that is a mix of natural and synthetic varieties. The rest, it's an intensely crafted chemical recipe. You've got 22% fillers, things like carbon black and silica, 13% oils, and about 1.5% of these crucial vulcanization agents like zinc and thiazoles that give the tire its toughness. Then toss in another 13.5% of various other additives, preservatives, and processing aids. They are brilliantly engineered to be incredibly durable and safe for driving, but unfortunately, that exact same durability makes them a seriously stubborn, toxic pollutant.
Researchers actually describe modern tires as representing, quote, combinations of elements novel to the Anthropocene, which is our current geological age dominated by human activity. I really want to emphasize that point. We have literally invented entirely new, highly complex mixtures of heavy metals, plastics, and synthetic hydrocarbons that the natural world has never, ever encountered before in history.
Section 3. Where does the tread go? From the road to the environment.
All right, so we've got this highly engineered, chemical-rich product rolling straight out of the factory and onto the highway. And I want you to think about this for a second. We've all had the experience of going to the mechanic and hearing, hey, your tread is completely worn down, you need new tires. But have you ever actually stopped to wonder, when those tires wear down, where exactly does all that missing rubber go?
Because it certainly doesn't just vanish into thin air. Over its lifetime, a single vehicle tire sheds somewhere between 1.2 and 6.7 kilograms of microplastic particles. That's roughly 10 to 16% of the tire's total original weight. We're talking millions of tons of this stuff getting ground down against the pavement and released into the world as microscopic particles every single year.
And when you trace the exact pathways of those invisible shed particles, well, they're surprisingly mobile. Some of the superfine dust gets swept right up into the atmosphere, traveling huge distances. But the vast majority of it just sits there on the asphalt, waiting until it rains. And when it does, urban stormwater washes this massive volume of microplastics straight down our storm drains. It completely bypasses treatment facilities and flushes directly into our local streams, rivers, and bays.
Moving on to Part 4, Toxic Runoff and 6-ppd, the Invisible Threats.
Which brings us to one of the most genuinely alarming discoveries in recent environmental science. We're not just talking about physical microplastic chunks anymore. We're talking about invisible chemical threats leaching into our waters. Enter 6-ppd quinone. This is the absolute smoking gun here. See, tire manufacturers intentionally add a chemical called 6-ppd to protect the rubber from breaking down when ozone hits it in the air. It's basically an anti-aging additive for your tire. But here is the major catch. As the 6-ppd does its job and interacts with environmental ozone as the tire ages, it transforms. It turns into an entirely new compound called 6-ppd quinone. And this transformation product, it is highly lethal to certain aquatic life.
To understand just how lethal this stuff is, let's break down some of this ecotoxicology data. Take juvenile coho salmon, for instance. They are extraordinarily sensitive to 6-ppd quinone. We're talking about mass die-offs at concentrations as incredibly low as 0.095 micrograms per liter. Chinook salmon are also highly sensitive to it. But what's really strange, and honestly a bit of a mystery, is that other species, like zebrafish or the water flea Daphnia, are far less sensitive. They show almost no mortality at those exact same levels. The precise biological reason why this chemical causes such massive die-offs, specifically in salmonids, is still a critical puzzle that scientists are rushing to solve.
And unfortunately, 6-ppd quinone isn't acting alone out there. The runoff from tires is just a toxic brew of other severe contaminants. Take heavy metals like zinc, which we mentioned is added during vulcanization. That causes significant mortality and reproductive decline in marine copepods, which are basically the foundation of the ocean food web. On top of that, you've got PAHs, or polycyclic aromatic hydrocarbons. These cause developmental defects in fish and wildlife. And get this, their toxicity is actually photoenhanced. That means they get exponentially worse when they're exposed to natural sunlight in shallow waters. It's a double whammy.
Section 5. The end of the road. Managing waste tires. So that brings us to the final stage of our explainer journey today. What actually happens when a tire can no longer be used safely on a vehicle? Well, the scale of disposal is just as wild as the production. Roughly 800 million tires become waste worldwide every single year. 800 million! That is a literal avalanche of incredibly durable, chemical-laden material that we suddenly have to figure out how to manage.
So how are we actually disposing of them? If we compare the United States and Europe, we see some differences, but they definitely share a heavy reliance on one major method. In the US, about 37% goes to energy production, which is a nice way of saying it's burned as fuel. 24% is recycled, and a pretty significant 15% still goes straight to landfills. Over in Europe, they've practically eliminated landfilling tires, keeping it under 1%, but they still burn about 40% for energy and recycle around 52%. Now, burning them obviously releases its own unique cocktail of emissions, but I really want to talk about that recycling slice for a second. Because when we say a tire is recycled, what we often really mean is downcycled. These waste tires get chopped up and turned into things like crumb rubber for artificial turf, rubberized asphalt, and shockingly enough, those bouncy shock-absorbing mats they put down on children's playgrounds. Sure, it keeps them out of a landfill in the short term, but it creates a totally new problem. By downcycling tires into playgrounds and sports fields, we are basically just relocating the source of those microplastic emissions right into our own local communities, giving those chemicals a front-row seat to leach continuously into the local environment. Ultimately, the persistence of a tire is a genuine marvel of modern human engineering. But, as we've explored today, it's also an absolute nightmare for our ecosystems. It doesn't just naturally biodegrade and disappear. It fractures. It breaks into smaller and smaller and smaller pieces, bringing that whole complex chemical cocktail along for the ride. I want to leave you with a final thought to chew on today. The next time you hop in your car, whether it's to grab groceries or commute to work, when you stop and consider the millions of invisible microplastic particles and toxic chemicals being left behind in our air, our soil, and our water with every single mile driven, what is the true environmental cost of the open road? Thank you so much for joining me for this explainer to uncover the invisible life cycle of our tires. Keep asking questions, keep digging deeper, and I'll see you next time.